I will do that soon. The PPTs will be available first on the LMS, and shortly the recordings also will be available on the LMS. Yes, Aniket is also joining now. Yes, Aniket, have you joined?
Yes, sir.
Why late? You are not in the first class.
Yes, sir. The
Hmm?
network issue, sir. I was trying to join from Mate, but not able to
Hmm.
join. I have shut restart and then join. Now it's joining.
Okay, whether the screen corresponding to the next topic is visible? It is IO organization.
Yes, sir.
So let us start with the next topic in this particular unit, that is IO organization. The long form of IO, as you know, it is the input output organization. Okay, uh, you can see in the logo of this uh, DECO, one part is the ICs, uh, which corresponds to the digital electronics, whereas the second part is the uh, architecture of a computer. Okay, so what a computer consists of: a CPU, memory, so which may be in the form of RAM or ROM, and IO, and that IO corresponds to input and output. Okay, so your computer is nothing but when you put together the processor, memory, and input output or the devices, then uh, what you get is the computer, the complete computer. Okay, and of course there is a communication path between the CPU and the peripheral. So memory and input output devices together, they are referred as peripherals many times, whereas whenever we are calling peripherals, so sometimes we called only IO as peripheral, whereas memory we refer as a memory only. Okay, but many times whatever CPU does with the memory, similar things it does with the IO. That is, with the memory, CPU with the memory, CPU is transferring the data. Either it is reading the data, or it is accepting the data from the memory, or it is sending the data to the memory. So similar thing it does with the IO. That is, either it is reading the data from the IO, or it is sending the data to the IO. But unlike the memory, the IO is slower, much slower than the memory. Whereas whenever it is sending something, sending certain bits, or receiving certain bits from the IO, these particular bits may not correspond to the data, but sometimes CPU may be sending commands to the IO, and and based on that, this particular input output devices, they are configured. Okay, so many times CPU need to configure the input and output devices. Usually it is called initialization of this particular devices. So you have heard the process of booting. Even before booting, so booting is related to the Booting is related to the operating system. Whenever your operating system is being transferred from the secondary device to the internal memory, then the time that is required for transferring your operating system program into the internal memory and actually taking the command of your computer, this particular process is called booting. So because operating system program is very large program, though it is very large, the whole of the operating system is not loaded into the internal memory, as we have discussed in case of the virtual memory. So it is just the illusion given to that particular program that if some operating system requires a huge amount of space, so that much memory is allocated in the virtual space, but actually it is not allocated. And whenever any feature is required, then as and when required, the certain pages are loaded into the memory. Okay, so the operating system is loaded. Before the operating system is loaded or booted, uh, the IO devices, whenever your system is on, then on the IBM type of processors, there is a program called BIOS, Basic Input Output System, or even before that BIOS, there is program called POST, Power on Self Test. So in the POST program, Power on Self Test, and the BIOS, what happens is that in the post, the peripherals are tested, input output peripherals, they are tested whether they are working or not. Okay, so usually if some peripheral is not working, you may get the before your computer boots, you may get the message that this is not working, that is your keyboard is not connected, or there is no keyboard, or it is not functioning well, or if memory is not working. In that case, even you get the messages related to memory also. Okay, so usually such messages you will find with the old computers. With the new computers or PC, because everything is working fine, such messages are not there. Okay, but with old computers you get that usually with replugging or after dusting and all this thing, after uh, 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 properly inserting reinserting the RAMs and all this, your problems are solved. But sometimes the input and output devices or your peripherals may be damaged, and because of that, and if it is necessary, if it is memory, then without memory your computer cannot go ahead, and in such cases your computer will not go ahead. So that is the power on self test it does. Okay, and after power on self test, the BIOS program execute, that is basic input output system. So all these post program and BIOS program, they are part of the ROM, they are part of the ROM, that is read only memory. So when you put on your PC, then the program which is there in this ROM is executed, and it initializes all the devices. Okay, so while initializing the devices, it may need to give commands to the input and output. So that is what I was discussing, that every time CPU may not be sending the data uh, to the output devices, or it may not be accepting data from the input devices, but in the beginning it is sending commands to the input and output devices, whereas with the memory it is less often that it is sending any command. So it is always, it is fetching either the instructions, or it is reading the data or writing the data to the memory. So that is how the memory differs from the input and output devices. Okay, otherwise CPU, what CPU does is that it is just transferring the bits to either memory or to the input output devices. So these particular bits may be either instructions, it may be data, or it may be command, or it may be status. Okay, for example, for the IO it may be status. Okay, so CPU may be sending commands to the input output devices for initializing it. Okay, or in between to change the mode of that particular input output device. Again, in between also, after it has been initialized, it may be sending the command to it. Then CPU may send the command to the IO to request its status. For example, to the printer, it may be sending the command, "What is your status?" So the printer, which is the output device, will be responding with its status. So what is its status? Whether it is paper out or it is printing, whether it is busy, and like that. Okay, so for each of the device, there can be status and command available. There can be each of the output input out. Am I audible? There was interruption.
Sir, voice is breaking.
Uh, Recheck now. Is it all
Yes,
right
sir.
now?
Yes, sir. It's all right now.
So there was an interruption. So here, uh, the IO devices, they send the status. Okay, so like printer, it sends the status to CPU. Okay, so whatever is transferred between CPU and IO devices, it is not only the data. The bits may not correspond to the data, but it may correspond to the status or the commands even. Okay, so let us go into the details of how this particular input and output devices are organized. So between the input and output devices and the CPU, uh, there is a input output module. Okay, input output devices are not directly connected to the CPU. Input output devices are not connected directly to the CPU. Input output devices are connected to the CPU through input output module. Okay, so between input output devices and CPU, there is input output modules, or this is also called input output ports. Input output ports. Okay, so you are aware that port, where you use the ports in day to day life, in the real world we use airport. Okay, so there is for that is, whenever aeroplane comes, it lands, then it cannot land anywhere. So there is a port, that is a specific location where it lands safely. Okay, so like that, your input output devices, they cannot be directly connected, and here there is a port, and through that particular port, the input output devices, they are connected. So it is called the interface. Okay, so it is called that input output devices are interfaced through input output port. uh, so they are either called port, or they are also called the module. Okay, so for connection with the CPU, you have the bus. uh, so between the input output devices and the CPU, there is the communication happens on the bus, and that particular bus we refer to as system bus, and it is divided into three different parts, that is address bus, data bus, and control bus. Okay, or address lines, data lines, and control lines. The address bus or address lines are used to locate one of the uh, uh, input output device. Okay, so actually same bus is used for addressing the memory. Okay, actually this particular bus architecture, it is common in the von Neumann architecture, whereas the MIPS architecture that we have used, it is not using a common bus. Okay, so there are many data paths which are available in the in that particular MIPS architecture. Okay, but in the architecture, the other architecture, von Neumann architecture, it is the single bus usually that is available. Okay, so now we are limiting our discussion to the organization which is of the von Neumann type, and uh, the similar things they apply to the other architecture. Okay, that means instead of having a single bus, you have the multiple bus or multiple data paths in case of uh, the other architecture. Okay, so system bus, it consists of address lines, data lines, and control lines. So address bus is used to select one of the input output device. Okay, in fact, it is not going to select directly the input output device. It is going to select the IO port, input output port, and then to this particular input output port connected to that is the peripheral, that is input output devices. Okay, so it first select the port, so through that particular port it either reads or write to that particular port, so that actual reading and writing happens on the data lines, whereas the control lines actually governs, or it actually controls whether the data is either sent to the IO module or data is received from the IO module, because address line just selects the IO module, whereas the control lines actually send the signal whether it is to be read or it is to be written, and the other control signals at what actual time the read will start and when it will read on this particular data line. So that is, everything is controlled by this particular control lines, and actual transfer of data happens on this particular data lines. Okay, so this is how is the common way the input and output devices are connected to the CPU. Okay, so CPU is not shown here. So on the other side of this particular system bus, it will be the CPU connected. Okay, so uh, the external devices or the IO devices, it may be human readable, that is, it may be screen, that is your monitor, it may be printer, it may be keyboard, or it may be a machine readable, that is monitoring and control system, that is some sensors and actuators usually in the industry. Then it may be a communication device called modem. So modem is nothing but modulator and demodulator. Earlier, before the internet, for the communication between two PCs, the telephone lines were used, and on the telephone lines, the bits were modulated and demodulated and then sent to the over the telephone lines, that is landline telephone lines, and then on the other side there is again modulator and demodulator, and then it converts those particular signal into the bits. Okay, so the purpose of the modem, that is purpose of the modulator, is to convert the bits into the signal, voice like signal, whereas the purpose of the demodulator is to convert the voice like signal into the bits. Okay, so that is modem, but nowadays we use this NIC, that is network interface card, and through this we connect to the internet, or we are on some network, and our machine it or our PC communicates with the other PC. Okay, so like that, there are n number of external devices which are either used for inputting purpose or outputting purpose, or both, for inputting as well as outputting. So that is why these devices are referred as IO devices. Okay, so input or output, or input output devices. This is the internal diagram of the IO input output port. So particularly the uh, input port, or it also you can say act as the output port. Specifically, it is not written because here you can see that the arrow shown is bidirectional. That means it has the capability of inputting as well as outputting. So this particular I/O module or I/O port, it receives the control signal, it receives the address and the actual data, or it receives the control signal and then it gives the status signal. Sorry, this is on the side of the device. So this particular device will be uh, receiving the control signal from the I/O module. Then the device, that is this particular device may be a printer device. Okay, let us say. So printer is connected to some I/O port. So it will be receiving the control signals from that particular I/O port or I/O module. Then it is sending its status to the I/O module. So I/O module in turn will send it to the CPU. Of course, this particular commands also I/O module will be receiving from CPU, and from I/O module this particular uh, device gets that particular command. So there is a control logic. So based on the commands received, the control logic uh, sets itself. Okay, so you can say that the printer is initialized. Then there is a buffer inside that particular device. So that particular device we are considering here now as a printer. So usually printer only inputs the data, but there are certain devices in which either you input the data also and you output the data from that particular device. Okay, for example, there may be hard disk controller. So hard disk controller device, it is used for either reading from the hard disk or writing into the hard disk. So in that case there will be two buffers, input buffer and output buffer. Okay, and that particular data will be actually used, and from that device it will go to the environment. For example, if it is a printer, then that data will be printed on the you can say paper. If it is hard disk controller, then that particular data will be actually written onto the disk in the magnetic form. If the data is to be read from that particular magnetic disk, data will be read and it will be put into the input buffer, and from where it will be taken into it will be taken to the CPU. Okay, these transducers are something, for example, in case of printer, it will be the printing head, that is which convert the bits into the actual printing of the characters. In case of the hard disk drives, it is the magnetic head which actually will be used for the purpose of magnetizing certain area or unmagnetizing certain area on the hard disk. Okay, so hard disk is divided into large number of cells uh, which are magnetized or not magnetized, and based on that zeros and one are stored on the hard disk. So this is how is the general working of any of the input output devices. Okay, now if we look into the speed at which the input and output devices are going to communicate with the CPU, then the different input output devices, they communicate at different data rates. Okay, or at different speeds as compared to the memory. The speed of the speed of uh, uh, you can say the communication with the CPU is much less than that of the memory. Okay, so reading or writing from memory, that too we are talking about the internal memory, so it is much faster than reading or writing from the input and output devices. Okay, so typically this particular bit rates, they are specified here. So on the x-axis you have this data rates which is in bits per second. So how many bits are can be transferred with with this particular devices, with various devices per second. So the first device, which is the, you can say, the keyboard, okay. So or what is the bit rate it should support, okay. So though keyboard may be able to transfer higher number of bits, but there is from the human side also, there is practically a limit as to how many keys we can press in 1 second, okay. So typically keyboard transfers around 10 to the power 2, okay, close to 10 to the power 2, that is 100 bits per second, okay. So it may be 90, 80 bits per second, okay. So this is the data rate with which the keyboard should or transfers data with the CPU. Mouse, because the mouse is supposed to transfer the location, and it is used in the graphical user interface, and that particular location is some number, so on the screen. So the bit rate is little higher than that. It is more than 100 bits per second, and up to 120 bits per second it may be. Then next device, IO device, is the modem. The speed of the modem is of course that is limited by the speed that is provided uh, by the telephone line, okay, landline telephone line. So it is around 10 to the power 5, okay, close to 10 to the power 5 bits per second, that is 10,000, it will be 10,000 or more than that, okay. It is more than that. No, it is 10,000. 10 to the power 5 is no, it is 1 lakh, okay. So uh, 5 zeros on 1, okay. So it is that speed, 1 lakh bits per second. So that is how the modem transfers, CPU transfers the data with the modems, okay. Then floppy disk. Nowadays floppy disks are not available. In our days, college days, these floppy disks were available. We have seen the computer without hard disk even. Whole of the operating system, it was there on the floppy disk. So a compact disk which can be stored uh, in the bag or in the pocket. So that was available, and for different programs, again, to run the basic program, different disk was there. To run the Pascal program, a different disk was available. So remove one disk and insert the another disk. So that was the way we used to work when the hard disk were not available. So the data rates with that was around 10 to the power 6 bits per second. Then with the laser printer, which prints the graphical quality, the data rate is typically more than 10 to the power 6 bits per second. Scanner, it scans your image, and every image is nothing but the pixel, uh, and that particular pixel, depending on the resolution of that particular image and the quality, it will decide the rate, and the typical rate, it is more than 10 to the power 6 bits per second. Then optical disk, because large amount of stored out of the data is stored on the optical disk, so it is the rate is around 10 to the power 7 bits per second. The Ethernet, the data which is transferred over the net, so it is 10 to the power 7, so 10 Mbps. Then with the hard disk, it is around 10 to the power 8 bits per second. For the graphical displays, graphical images, or the videos you play, so the data rate is typically high. close to 10 to the power 9, that is 1 GB, 1 gigabits per second, whereas with the gigabit internet, so the internet, the slots that are available on the PCs, so it has the capability of 10 to the power, or the ports which are available on the PCs or laptops. So it is up to 10 to the power 9, that is 1 Gbps. So these are the typical rates, data rate with which a particular device communicates. Okay, so the IO module function. Okay, so it has got the timing and control. Uh, it need to look toward the timing and control. CPU communication, it has to look after the communication with the CPU, because the IO module or IO port, it has to it is the interface between the input output devices and the CPU. So it communicates with the CPU, it communicates with the on the other side with the devices. Okay, so typically a printer port has to communicate with the CPU, and the printer port has to communicate with the printer. Then it has to do the data buffering. Okay, so there will be typically input buffer and output buffer in it, and if any errors are there, then it need to detect the error. So it need to communicate with the device to see if any errors are there. Okay, the steps in I/O communications are like this. So CPU checks if the I/O module device status. So what is the status of that particular device? For example, it is printer. It need to work with the printer. So before it actually transfers any data with the printer, it first checks the status of the printer. Then I/O module returns the status. Okay, so the I/O module will in turn contacts that particular device. Let us say it is printer. So printer, if it is ready, then it will return with its status that it is ready, and the IO module then send the status of the printer to the CPU. So if CPU gets that it is ready, then CPU requests the data transfer. Okay, so CPU requests for the transfer of data to that particular IO module, and then IO module gets the data from the device. Okay, so typically it is for the input device. Okay, for that, for our so that particular device may be scanner, or that device may be the hard disk reader. So it reads the data from the that particular input device. Then IO module then transfers the data to the CPU. So first data comes to the IO module from the input device, and from IO module the data goes to the CPU. Okay. Then there are variations. That is because CPU does not contain huge memory, and in that case, the data which is there, which is obtained or which has been read from the I/O, need to be stored somewhere in huge location, and usually it is stored in the memory. So from CPU it need to be transferred to the memory. So instead of transferring it into to the CPU, and from CPU transferring it to the memory, so another variation is used, that is called DMA, that is direct memory access. So the data is transferred from IO directly to the memory, or the data is transferred directly from the memory to the IO. So such variations exist. So this is typically the internal diagram of I/O. Already we discussed this one in brief. So typically it contains the data register, that is the buffers. It contains the control registers, wherein it receives the command. It has the I/O logic through which it controls the way it communicates with the input output devices. Okay, so typically this is the architecture of some general IO device like 8255. Okay, so 8255 is a programmable peripheral interface So it has got different ports for communication with the different devices like printer. So the printer typically is connected on this device like 8255, that is programmable peripheral interface. Okay, and you can connect one device on this particular port. Okay, so such devices, it has got many ports. So one device may be connected on this port, another device may be connected on this port. So like that, this PPI, that is programmable peripheral interface, may contain many ports for connection to connect to the input and output devices. Okay, the actual techniques for transferring the data are of three types, that is programmed input output, interrupt driven input output, and direct memory access type of the transfer. Okay, so this particular transfers uh, are shown here with the flow charts. The first type of transfer is from that is CPU is involved in that, and CPU polls the IO devices. Okay, so issue the read command, or it checks first the command. So if issue read command to the IO module, so check the status of the IO module. If the status is not ready, then it will wait for that particular device to be ready, and if it is ready, then it actually goes for reading that particular it goes for reading from that particular input output module. Okay, or it may either read or it may write, or after reading it, it will write into the main memory. Well, exactly reverse will happen in case when uh, it need to send data to the output. Okay, if it is not done, then this will repeat, and then this will proceed. So after one device, it will go to the another device. So this is called programmed IO. Okay, whereas in the interrupt driven IO, so interrupts are used. That is, CPU will not check the status of the input output device. So it will issue read command to the IO module that whenever you are ready, let me know. Okay, so for example, it may be printer. CPU has just given the bulk of data for printing, then CPU will be doing some other work. Okay, so it is doing some other work, and while doing that particular other work, CPU is interrupted. So when CPU is interrupted, then that time only, when it is interrupted, it will read the status. It will check whether there is any error. If there is no error, then probably because CPU that device is ready, it got this particular interrupt, and then it will do that particular operation why it was interrupted, to read the word from that device and write it into the memory. While it can be reverse also, it will read the data from the memory and it will write it to the IO, and after done, then again it will resume into the work it was doing, and again it may be interrupted. Okay, so like that it will do. So this is the interrupt driven IO. Okay, whereas in case of direct memory access, the CPU will issue the command, and it will issue the command to the DMA, that is direct memory access controller. So this is a different controller which acts on behalf of the CPU, the transferring of the data. Okay, so CPU does not actually transfer the data. Here the DMA controller actually transfers the data. So it CPU tells to the DMA which memory area to be used and from which device the data is to be transferred, and then CPU works with the instruction. So when actual data is to be transferred, that means when that IO device is ready to transfer the data, it interrupts. Now it interrupts, or that particular interrupts go to the DMA controller, and that particular DMA controller, what it does is that it transfers the data either from the IO to the memory or from memory to the IO. So that is why it is called direct memory access. Okay. After that means when it is doing the transfer, then at that time CPU sits idle. That means the system bus is used. System bus is used by the DMA controller. So it directly reads from the input device and it writes to the memory, or it may be in the other way also. It reads directly from the memory and it writes to the output device. Okay, after it has transferred, that is, this DMA is used for when huge amount of data is to be transferred from input output device to the memory, or from memory to the input output device. Okay, for example, it may be data, huge amount of data to be sent to the printer. It may be saving of some file from internal memory to the hard disk, or it may be opening of the file from hard disk and to be loaded into the internal memory. So in such cases the DMA controller is used. Okay, so after DMA controller has finished, the DMA controller then transfer the control to the CPU, and then the CPU works with the data, works with the program it was doing. Okay, so three different types of transfers are there from IO to from the IO, that is input and output devices. Okay, so typically this particular programmed IO has this particular characteristics. Okay, so lot of time of CPU is wasted if in case of the program IO, that is checking the status and then communicating, whereas so this is this is the detail of the programmed IO which was shown in the flowchart. Even you can go through this, just explain. Then IO commands need to be issued. Okay, and when these particular commands are issued, so that differs in the different things. Okay, then IO need to be addressed. So every input output port has got a different address, and that address is unique address, and usually CPU gives that particular address in case of the IO programmed IO. Then in case of interrupt driven IO, the CPU is waiting for long time for IO, so that particular waiting time is not required. CPU can effectively use that particular time for some other purpose. So no repeated request will be there to the for the device to check the status. Okay, so in that case, that particular device also may not be able to function efficiently if it get repeated requests. Then IO module interrupts when it is ready. Okay, so this is how the basic operation happens with the interrupt driven IO. So these are the routines, the uh, the sequence of operation that happens in the interrupt driven IO. Okay, so you have the advantage with the interrupt driven IO that the time of the CPU is reduced. Okay, whereas the third type of data transfer is direct memory access type of data transfer, and it is used for huge transfer of data. Okay, so so the additional module is required, that is the DMA controller is required, and DMA controller takes over the CPU for the purpose of doing this particular IO. So this is the typical internal diagram of this particular DMA controller. It consists of the data count, how much data is to be transferred from IO to memory or from memory to IO. This is the data register. So when it is memory to memory transfer, data is stored here, otherwise it may not be used. The address register is used to address memory, so where the data is to be transferred into the memory or it is to be read from the memory. Whereas the control logic, it is used to give the control signals. Okay. So in the DMA operation, CPU tells the DMA controller about the read-write operation, whether it is the read IO is to be done or write IO is to be done. It gives the device address from which IO device it is to be read. It also gives the starting address of the memory block to where the data is to be transferred or from where the data is to be transferred, and it also gives the amount of data to be transferred. Okay, so in the beginning itself, the DMA controller is initialized by CPU. Okay, then CPU carries with the other work after the DMA has been initialized. Then the DMA controller deals with that particular transfer. So whenever the suitable time happens, whenever that particular data is to be transferred, then the DMA controller sends interrupt when it is. So it starts with that particular transfer. It uses the system bus, and after the transfer is over, the DMA controller sends interrupt when it is finished. Okay, so DMA controller takes over the bus for a cycle, then transfer of one word or data happens, and then the CPU does not switch the context in this case, and the CPU suspend just for it to access. So CPU slows down because of this. Okay, for this is called the cycle stealing. That means for one cycle, DMA controller transfers uses the data bus, whereas for the next cycle, the CPU uses the system bus. Okay, so because of this, both data transfer also happens, and CPU also execute the instruction. So this type of transfer is called cycle stealing. Whereas, so this is how it happens. This is the CPU. These are the buses: data bus, address bus, and control bus. So when CPU is using the bus, then this switch is towards the data bus is connected to CPU, and data bus, address bus, and control bus are connected to CPU. But when DMA controller needs to transfer directly from the IO to the memory, then in that case the data bus is connected to DMA controller, the address bus is also connected to it, and the control bus is also connected to it. So the DMA controller gives the address of the memory, DMA controller gives the control signal to the IO devices, and actual transfer of data happens on the data bus directly from the input device to the memory, or from memory device to the uh, to the IO. Okay, so here the sequence of action happens. Usually this particular buses are used by CPU. So first of all, the DMA controller raises the request that it need to transfer the data. So the request goes to the DMA controller. The DMA controller in turn gives the request, hold request to the CPU. So CPU holds the buses. That means these buses goes into tri-state. So the buses now they can be used by the DMA controller. So it acknowledges, the CPU acknowledges that now you use this particular buses. So now the buses, the switches are in the position that are shown here. So DMA controller gets the buses, and then the DMA controller acknowledges to the request of the this disk controller. Okay, and then the disk controller actually starts the or actually responds with the data. Okay, so it will be sending the read or write signals to the memory and disk controller. Okay, so if it is four types of signals are there: IO read and IO write. IO write, these are for the disk controller, whereas memory read and memory write, these are for the memory. Okay, so if it is IO read signal generated, then it will be memory write signal generated. So IO read signal and memory write signal will be generated simultaneously, so that it will be read from the IO and return into the memory. So actual transfer of data happens here. whereas it can be IO write and memory read. So in that case, the data will be transferred from the memory and it will be returned to the IO. So like this, the sequence of operation happens with the DMA controller. Okay, so typically the device 8237 is there, which uses this type of which implements the DMA, that is direct memory access. Okay, so three different types of transfer we have seen. Now this DMA can be used in various fashion. Single bus, it may be used in the single bus. It may be used in a single bus and integrated DMA IO, or it may be used in the alternative DMA configuration like this. Okay. So this is how is the IO organization. So we stop here with the IO organization. So if you have any doubts, you can ask your queries. So have you understood the IO organization? How input and output devices are connected to CPU? So they are connected through IO modules, and there are three different ways with which the data transfer occurs: programmed IO, interrupt driven IO, and direct memory access. So this is how is the IO organization. So any queries, students? Yes, all are there active.
Yes, sir.
So understood this IO organization.
Yes, sir.
Yes, sir.
So most of the part of the fifth unit is over. Now the advanced part which is there in the book of Patterson, so that is remain. So of course it is on the virtual memory only, cache and virtual memory only, and it is the design or the numericals which are there on this, and few advanced concepts. So for that I shall be preparing few videos and I will upload it on the LMS. Later on you can watch it. So as far as unit test is concerned, you can limit your study to the book of Stalling, and for the end sem examination you should look forward to study from the book of Patterson. Okay. So as far as our live classes are concerned, uh, in the next class we shall be going for the first topic from the next unit, that is the sixth unit. Okay, so in this unit we have discussed the characteristics of the memory, the organization of the memory. So we have seen the organization of two types of memory, that is the cache organization and the virtual memory, that is the internal memory organization. And later on today we discussed the IO organization and the different uh, types of IO devices, its characteristics, their typical bit rates, how it is interfaced, and what are the different methods of data transfer with this particular IO we discussed in this. Okay, so I hope you have understood the memory organization and IO organization. Okay, so typically we have discussed now how the computer is from inside, how is the memory, how is the IO, how is CPU. We have seen what is there inside the CPU also, particularly the MIPS processor, whereas the architecture of the von Neumann type of processors is a little simpler than the processor we have discussed. For example, it is the 8086 processor or 80386 or Pentium type of processor. Okay, though Pentium processor is not as simple as 8086 processor, but it is advanced version of 8086 only or 80386 only. So that way, internal architecture of 80386 you'll be studying as a part of your second semester subject, that is processor interface, processor architecture and interfacing, or that subject is microcontroller and microprocessor. Okay, so we shall stop here for today, and we shall resume in the next class. Tomorrow there will be test. You should be ready for the test. The test will be MCQ test in the morning. And when is the unit test for DECO? I get it is on 1st December, or what is the date? Or is it today?
December, sir.
It is on 5th December.
1st December.
1st December. Okay. It is on 1st December. Okay. So tomorrow there will be unit test. I think we already have a short unit test on 5th unit. So I shall try to schedule 2 tests tomorrow, so that you will get exposed to more number of questions. So tomorrow at 8 o'clock, be ready for that particular test. And on
Sir,
Monday.
please upload. Hello, sir.
Yeah. I will
Sir,
upload the PPTs. I will upload, and even the videos also I will try to upload. But because for videos, for downloading, it takes time, and for uploading also takes time. So